All right, now what we're going to be doing in this video is we're going to be looking at the fact that there are some common argument forms that when you notice that after you translate the argument into symbols, when you notice that it has the following structures, you'll be able to know already whether the argument is valid or not. There's going to be 4 of these common argument forms that you'll already know are valid. And then there's 2 that turn out to be fallacies. They're not valid. They're invalid argument forms. Okay? You need to make flashcards or something, because you will have a question on the final that asks you to give the reason why an argument is either valid or a fallacy, and you have to actually use these names. So do a flashcard with modus ponens and modus tollens and all of that on it, and then on the other side put the argument form and start recognizing these. Now, to help you on the test, when I ask you to choose the argument form and whether the argument's valid or not, I will make it multiple choice. So you won't have to actually know how to spell everything. You'll just need to know how to recognize which one, kind of be able to match the argument form to its name. Okay? All right, so let's take a look at how these 4 that are in this box, these are all valid. Let me get back to my normal color. These are all valid. Okay, so if I were to do a truth table for these, we've actually already done a truth table for a couple of them. If I were to do the truth table, it would turn out to be true for all cases. Okay? So you're going to have to try to have something that helps you to recognize the name. So on the first one, modus ponens and modus tollens, they're both true. A whole lot of these argument forms will start with this conditional. You see that here, here, here. You'll also see it on the 2 invalid ones. Okay? So that's a starting statement that's on a lot of them. Now, with modus ponens, what I do to remember this is what I'm noticing is that P is above the line and that Q is below it. And P implying Q is sort of what I think. I mean, I that's what I use, is I see the P is above the line, Q is below it. Okay? That's the conditional. This one's going to be valid because it matches the conditional. So that's what a conditional would be. And notice that ponen starts with a P and you have a P right there. Okay? All right, now on the second one, modus tollens, we have the original conditional statement, and then not Q followed by not P. That would be the contrapositive. Contrapositive. Okay? And the contrapositive of a statement is equivalent to the statement. So that helps me remember that this one's going to be valid because the contrapositive and the original conditional would have been the same. And then I just remembered that this is the other modus. So this is modus tollens. All right, now the next one that we know is going to be valid even without doing a truth table is this one, disjunctive syllogism. Okay, now the disjunction, you know, a disjunction is a statement where you have an or. So that helps me remember that that's the disjunctive syllogism one. But not just any argument with an or in it would fit this. Okay, let's think about what this is saying. It's like it's saying I'm going to get a red car or a blue car. I'm going to buy a red car or a blue car. I didn't buy a red car, so I didn't get a red car. And then it says that the conclusion that should follow is that I got a blue car. Okay, so I'm going to get a red car or a blue car. I didn't get a red car, is what the second premise says. Therefore, I must have gotten the blue car. So you can hear the logic, I think, on that one. By the way, because it doesn't matter which way on an or you do things, it could have been, I'm going to get a red car or a blue car. I didn't get a blue car, therefore I got a red one. That would also be considered disjunctive syllogism. Okay? So the disjunctive syllogism could be like it is there, or it could have P or Q, not Q, implies P. Okay? Both of those. All right, now this one's logical. This one is called reasoning by transitivity. All right, so for this one, think, let me write it up here. If I do my homework, I'll pass the test. If I pass the tests, okay, then I'll pass the class. Therefore, if I do my homework, I'll pass the class. Do you see how this Q and that Q are the same? You see how those spots are both Q's? It's like you're taking out the middleman. So if you do your homework, you'll pass the test. If you pass the test, you'll pass the class. Therefore, if you do your homework, that's going to lead to you ultimately passing the class. That one's always valid. Okay? And that one's not hard to remember because it sounds valid, and it's the one that involves the if-then 3 times. Okay? The one with the arrow on all 3. Okay? So those 4 are the valid argument forms. So you need to start connecting the name of the argument with the structure of the argument in symbolic form. Okay? All right, now let's look at the 2 common fallacies. Okay? These are argument forms that would not turn out to be all true if I did a truth table. Notice they both start with the regular conditional, P implies Q. So this one is P implies Q and Q, and it's saying that that would mean that P would follow. Okay. With this one, it's the original conditional, then it has not P above the line, and then the conclusion would be not Q. Now it's easy to remember these names because look at Q followed by P. Isn't Q followed by P? Isn't that the converse? That's how I remember it. And wouldn't not P followed by not Q? Isn't that the inverse? Okay, so that's those names, and then the ones. So then these would be fallacies, meaning without even doing the truth table, if it has that structure, then I would know that that argument is not valid.